So we're repeating that same thermodynamic process where we use our thermodynamic properties chart from the appendix, and we're going to this time be looking for delta G values. And we're going to put them in order, and then we're going to do products minus reactants. Don't forget, before you do anything, and I like to do this first because I, again, will forget if I don't do it first, is to put your coefficients out there, because the numbers in this chart here, they're only per 1 mole. And so like if you have a coefficient, that means you have more than 1 mole. So we have to scale it up basically. So I'm going to go to the C's for the CH3OH. There it is. And I need to make sure this is the liquid form of it. So that's the top one. And the column, I don't have the S column showing, so that's the G column. So on the right is the G column. So that is negative 166.6. So those two terms will be multiplied. And then I'm going to jump to the CO2s because that's also in here. Oops, where to go? There it is. So CO2 as a gas, and then you can see that the CO2 value, oops, it's kind of not showing well. There you go, is negative 394.36. And then if I go to the water, so that's going to be hydrogen. And you can use the search function on there, but it doesn't just search for in the chart. So and I recommend using that Control F instead. But here's the water, and the delta G for this one is negative 237.1. And then I'm going to go to oxygen, but as a note, oxygen is an element in its standard state. So that's going to basically mean that it's going to be 0, but I do not mind proving it. CNO, there you go. And then remember, my trick is that I go ahead and I actually write delta G of reaction under the arrow. And then I take my 2 reactants right there. That's what they're equal to. And I add them together. Minus parentheses. And this is just going to be 0, so I don't even really need to keep that one in there. I can. But I'm just going to be adding 0 in. So I'm going to put this one over here. And if I want to squeeze in plus 0, it's fine. And then I'm going to get my chart or my calculator up, and I'm going to say 2 times negative. Let me bring this down. So 2 times negative 394.36 plus 4 times negative 237.1 minus parentheses 2 times negative 166.6. So I'm doing a quick check, make sure all those terms were negative that I put in. That looks good. And so I have that my final value is 1403.92 kilojoules per mole. That's a process you've seen before. It's not new. We're going to do it one last time for these delta G's, and then we're going to find another way to calculate delta G. And that's what the next section is all about.